Okay, it is now time. Hello, everyone. My name is William Nelson. I am the International Sales Team Leader here at FORUM8. Thank you for being able to join us today for our Dealer Seminar Online 2021 in Indonesia.
Oke, baik Bapak dan Ibu sekalian, inilah saatnya kita mulai webinar kita untuk hari ini. Saya memperkenalkan diri, nama saya William Nelson, saya adalah International Sales Team Leader dari FORUM8 dan hari ini kita akan mulai acara FORUM8 Dealer Seminar Online 2021.
We are very grateful for our partners, Fujicon Indonesia, Sipilpedia, ITNS, for being able to come together and put a great seminar together for you guys today. We are very excited to show you what we have today.
Ya, kebahagiaan sekali, kebahagiaan bagi kami bahwa hari ini saya bukan dengan tim FORUM8 saja, tetapi ada bekerja sama dengan Fujicon, bekerja sama juga dengan Sipilpedia, dan bekerja sama juga dengan ITNS dalam menyelenggarakan acara ini.
Today's seminar will be run in 2 languages. We will have English and Indonesia interpretation available. I am going to now turn on the Zoom real-time interpretation function so that you can choose which language you would like to listen to.
Webinar hari ini akan didukung oleh mode interpretasi atau mode penjuru bahasaan 2 bahasa, yaitu bahasa Indonesia dan juga bahasa Inggris. Jadi mulai sekarang saya akan mengaktifkan mode penjuru bahasaan tersebut. Nanti Bapak dan Ibu sekalian bisa memilih untuk masuk ke channel yang diinginkan.
Okay, the interpretation setting is now online. From now on, we will do real-time interpretation. If you would like to listen into your preferred language, please check the screen, the bottom of your screen for the interpretation button, and you can select which language you would like to listen to. Okay, now I will continue on. So, for today's agenda, we will start with the opening speech. As I'm giving a quick speech from FORUM8 here today. And then we will move on to our special lecture with Professor Irwin from the Department of Architectural Engineering in the National Institute of Technology. And then after that, we will move into FORUM8's 3 presentations. We have a VRCG seminar presented by myself. Then we have a UC1 FEM seminar presented by my colleague, Hinako. And then we have one more final presentation called the Iem and Vrcg Seminar. Again, this will be hosted by myself. And then at the end, we will have our final remarks and a Q&A session for FORUM8. At the end of the special lecture by Professor Irwin, we will also have time for questions. If you have any questions, please use the Zoom raise hand function so that we can get your questions answered. So just to give you a quick introduction to who we are as FORUM8, we just had our 30th anniversary just a couple of years ago. And we are a Japanese-based company located here in Tokyo. I'm actually sitting in our Tokyo office right now. So I'm really grateful for the opportunity to speak online with our customer, or our guest today in Indonesia. We were founded in May 1987, and our current staff is about 288. So we're a pretty large company here. We have, actually, this number is a little bit old. We're over our 130,000 number of users for our civil engineering software. And most of our users are construction consultants. They are located also within the public sector, working for government organizations or in automobile universities and research institutes. We have 11 offices located across the world here. You can see we have a number of offices located in Japan itself, but we also have world offices located in Vietnam and Myanmar as well. We do have Shanghai, Taiwan, and Qingdao offices, with partner offices in the UK, Korea, and Sydney, Australia. And we also have a wide expanding range of dealer networks as well. FORUM8 is a highly awarded organization here within Japan. We've received various numbers of awards, which can all be seen on our website. One of these awards is the 8th Monozukuri Japan Awards from the Japanese government. And this is us and our president, Yuji Ito, receiving the reward in Tokyo. Some of our software is also based on hardware as well, with some of our drive simulators receiving accreditation for use in the Japanese National Police Agency to be used for driving schools across Japan, so that our simulators can be used to train students in a safe environment through various scenarios so that they can get the training that they need. We also have various other case studies and organizations that have been utilizing our snowplow simulator as well. And we've also been kind of developing various resilience designs and case studies to ensure that any national disasters that come to Japan are simulated within our software so that the customers can understand what is going on. We've received various rewards for this resilience progress within our software. And we also offer full training courses for our software through this ICT Master Training course as well. So if you're interested in learning more, we also offer either one-on-one demonstration, one-on-one training, or larger classes available for training to learn our software and become a master of the simulation software itself. FORUM8 is also dedicated to the Sustainable Development Goals developed by the UN, utilizing our software to achieve these goals through the visualization and simulation process. For an example of this, we have our earthquake simulator to help build sustainable housing throughout the nation so that we can simulate the various earthquakes. Japan has quite a few number of earthquakes throughout the year. So being able to simulate these earthquakes and understanding how they can work and what kind of damage that they could potentially cause, and then balancing and ensuring that these buildings are built up to standards for these codes as well. As a CRM Best Practice Award, we've won the award for 6 consecutive years since 2020. And we've also received various other awards for our women in the workforce as well. Next, I'd like to introduce our Design Festival. Last year, we had the 14th Design Festival. The Design Festival is a kind of a celebration event. I'm going to talk a little bit more about what it is specifically, but it's kind of a celebration of event of inviting all the users that we have and how they've really utilized our platform software in their for their projects, and then showcasing those projects and awarding those projects that really go above and beyond. So for example, on day 1, we have our autonomous driving conference where we invite experts in autonomous driving and have a seminar and special lectures regarding the progress on autonomous vehicles and where they're going next, and then how FORUM8 is also supporting those drives. And then for the second half of day 1, we have the 19th 3D VR simulation contest, which is what I just mentioned, where we invite the companies who have been utilizing our software in unique ways, and then reward their progress and their excellence on their projects. An example of these, I'll talk a little bit more about this in the presentations later, but the Grand Prix award winner was a company that focused on a bridge repair simulator, and it's very interesting, so I really encourage you to stick around and find out more about that. Day 2 is focused on our Student Design Awards, so if you are a student and interested in working with virtual design, we really encourage you to check this out. And again, I will talk more about this in my presentation later. Okay. We've also been recently working with our virtual platform system, which is our idea of creating a 3D environment for any kind of space, so that it has a digital twin where you can walk around and interact with to help bridge the gap that COVID-19 has really caused in recent years. We have our virtual showroom and our virtual office system that will also be introduced later. We've also been working on an infrastructure digital database system targeting our BIM customers to gather and collect one open source database to make sure that everyone is on the right page and everyone is meeting the same standards for their projects as well. Since this won't be too long of an introduction here, I'm just going to go ahead and skip here. And again, we'll talk a little bit more about this at the end, but let's go ahead and get towards our special lecture here. So let me get this here. Here we go. So without further ado, I'd like to introduce our guest speaker. This is Professor Irwin here. He is a lecturer and architect. He is from the Department of Architectural Engineering, National Institute of Technology. And we're very excited to hear his presentation on the latest information on BIM utilization in Indonesia and the construction industry. So please, without further ado, if we can go ahead and introduce Professor Irwin. Oh, I apologize. I'm also going to be supported by Fujicon staff, Mr. TS, or Mrs. TS will also be helping me with the moderation of this seminar today. Thank you very much.
Thank you for your presentation, Mr. William Nelson. Setelah ini kita akan mendengarkan pemaparan dari Profesor Erwin Yuniara Hadian, dosen dari Institut Teknologi Nasional Bandung, Indonesia, yang akan menyampaikan pemaparannya terkait dengan BIM. Waktu dan tempat dipersilahkan, silakan Pak Erwin mungkin dapat menyampaikan.
Oke, terima kasih. Mungkin saya minta share screen-nya. Baik. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Selamat siang, Bapak dan Ibu, saudara-saudara sekalian. Semoga kita selalu dalam keadaan sehat walafiat dalam lindungannya. Perkenalkan, nama saya Erwin Yuniara Hadian. Saat ini saya berprofesi sebagai dosen di program studi arsitektur Institut Teknologi Nasional Bandung. Sebelum memulai, saya ingin mengucapkan terima kasih kepada Mr. K, kemudian Yoko Yamasan, Mr. William, dan Miss Kyotani dari FORUM8, lalu Bapak Andi dari Fujicon Indonesia, ya, serta seluruh pihak yang mendukung terselenggaranya seminar online ini, yang telah memberikan kepada saya kesempatan untuk menyampaikan materi dengan judul Informasi Terkini Penerapan Building Information pada Industri Konstruksi di Indonesia. Semoga materi ini akan menambah wawasan dan motivasi bagi kita semua untuk terus dapat menggunakan dan mengembangkan metode BIM ini untuk kemajuan industri konstruksi di Indonesia. Baik, sebelum mulai, ini biodata saya. Nama saya Erwin Yuniara Hadian, Sarjana Teknik dan Magister Teknik. Pendidikan Sarjana Teknik saya selesaikan di Institut Teknologi Nasional Bandung tahun 1997. Kemudian mengambil Magister Arsitektur di Institut Teknologi Bandung tahun 2008. Sedikit pengalaman yang bisa saya share di sini. Saya mulai bertugas sebagai dosen mulai tahun 2002 sampai dengan sekarang. Lalu selepas lulus sarjana teknik, langsung berkecimpung juga di bidang profesional sebagai arsitek sampai saat ini. Ya. Agenda yang akan saya sampaikan atau akan saya paparkan, perkenalan, barangkali tadi sudah disampaikan, lalu pengantar tentang BIM, kemudian sejarah perkembangan BIM, kemudian langkah strategis penerapan BIM di Indonesia. Ya, di situ ada peran pemerintah, peran dari masyarakat industri konstruksi, peran institusi pendidikan, kemudian terkait dengan pencapaian pekerjaan-pekerjaan berbasis BIM di Indonesia. Ya, di sini terkait dengan kalau di kementerian itu ada yang berkecimpung di bidang cipta karya, bina marga, sumber daya air. Kemudian adanya dukungan vendor dari perangkat digital. Baik, ini sekilas mengenai Institut Teknologi Nasional di mana saya bertugas, ya, berdiri sejak tahun 1972. Saat ini terdiri dari 3 fakultas, ya, Fakultas Teknologi Industri, yang terdiri dari program studi teknik elektro, teknik mesin, teknik industri, teknik kimia, teknik informatika, dan sistem informatika. Kemudian ada Fakultas Teknik Sipil dan Perencanaan yang terdiri dari program studi teknik sipil, teknik geodesi, perencanaan wilayah dan kota, kemudian program studi teknik lingkungan. Kemudian Fakultas Arsitektur dan Desain yang terdiri dari program studi arsitektur, di mana ini menjadi tempat saya berkarya, begitu. Kemudian program studi desain interior, program studi desain produk, dan program studi desain komunikasi visual. Lalu di ITENAS juga kami membuka program studi magister, diantaranya magister teknik mesin, teknik industri, dan magister teknik sipil. Baik, itu sekilas perkenalan mengenai saya dan institusi di mana saya menaung. Oke, BIM, ini gambar ini saya ambil dari www.bimcommunity.com. Barangkali ini sudah cukup banyak, ya, rekan-rekan Bapak dan Ibu sekalian sudah mendengar apa itu BIM. Ini kebetulan juga gambarnya, kalau saya lihat ini adalah gambar semacam instalasi utilitas, ya, pada sebuah gedung. Jadi kalau kita bicara dari terminologinya, menurut Eastman di sini, bahwa BIM ini adalah sebagai pendekatan baru, ya, yang mewakili proses pengembangan secara digital, ya, atau proses pembangunan secara digital. Di sini BIM digunakan untuk memfasilitasi pertukaran dan interoperabilitas informasi dalam format digital. Jadi di sini yang dimaksud adalah bahwa dalam sebuah proyek itu tentu ada informasi yang dipertukarkan, ya. Informasi yang dipertukarkan ini menjadi sangat penting terhadap keberhasilan suatu proyek, gitu. Kalau kita bicara pihak-pihak yang terlibat di sana, tentu banyak sekali informasi yang saling ditukarkan, gitu, ya, misalnya antara disiplin ilmu arsitektur, disiplin ilmu sipil, disiplin ilmu mechanical, electrical, dan plumbing. Sehingga pada zaman sebelum kita menggunakan teknologi digital, ya, kita masih menggunakan paper base atau menggunakan kertas. Di sana nampak ada banyak sekali kesulitan-kesulitan ketika kita harus melakukan pengecekan, melakukan koordinasi gambar, melakukan menelusuri misalnya di mana terjadi kesalahan gambar, gitu, ya. Nah, karena data-data tersebut masih bersifat manual atau masih bersifat ya, belum secara mudah bisa dipertukarkan, ya, dan diinteroperabilitaskan, atau di bagaimana data itu bisa kita pertukarkan, informasinya bisa dimanfaatkan oleh pihak lain, gitu. Nah, kemunculan teknologi digital ini pada awalnya baru sebatas membantu para desainer untuk memudahkan proses barangkali penggambarannya saja, baru sampai di situ. Namun seiring perkembangan waktu, ternyata tidak hanya gambar saja yang perlu dikoordinasikan, ya. Banyak informasi lain di luar gambar yang memang perlu dikoordinasikan dan dipertukarkan demi tercapainya keberhasilan sebuah proyek. Jadi barangkali itu yang menjadi awalnya. Jadi bahwa BIM ini adalah dia mewakili proses pengembangan secara digital. Jadi kata kuncinya pertama adalah digital, kemudian yang dipertukarkan adalah datanya atau informasinya, ya, untuk kepentingan penyelesaian sebuah proyek dengan baik. Kemudian menurut Jiang tahun 2019, BIM ini digunakan pada semua siklus proyek, ya, mulai dari desain, konstruksi, operasi, bahkan sampai pada tahap manajemen, maintenance, ya, maintenance, dan disitulah ujung-ujungnya juga bisa sampai pada tahap kita melakukan demolish atau penghancuran bangunan untuk kemudian dibangun kembali. Banyak kasus-kasus di mana data itu tidak akurat gitu ya. Kemudian ada perencanaan perencanaan baru pada sebuah tempat gitu. Namun data kondisi existingnya tidak akurat, ya, ketika mulai melakukan proses misalnya pemancangan fondasi, ternyata di sana ada melintas misalnya pipa atau melintas kabel tegangan tinggi di dalam tanah gitu ya. Nah, ini karena barangkali data operation dan maintenance pada sebuah tempat itu tidak tersedia dengan baik, sehingga dia merusak merusak kondisi existingnya, ya. Nah, atau bisa juga di sini yang dimaksud operation dan maintenance ini adalah sebuah proses di mana ketika proses desain, konstruksi dan operation dan konstruksi itu sudah selesai, ya. Pada saat mereka melakukan operasi bangunan, mengoperasikan bangunan, memaintenance bangunan, itu menggunakan data-data yang sudah ada mulai dari tahap desain, sehingga pastinya itu adalah data-data yang sesuai dengan kondisi apa yang terpasang di lapangan, atau saat ini kita kenal dengan yang istilahnya kalau pada sebuah proyek itu adalah as-built drawing, ya. As-built drawing itu dimanfaatkan untuk proses operation dan maintenance, ya, untuk perbaikan pipa yang bocor misalnya, perbaikan misalnya pengecatan dan lain sebagainya. Kemudian menurut Hussein dan Yoh ini tahun 2018, ya, bahwa BIM ini tidak hanya bisa digunakan untuk bangunan baru, ya. BIM ini juga bisa digunakan pada existing building, ya. Contohnya misalnya saat ini banyak sekali bangunan-bangunan milik pemerintah yang kondisinya sudah terbangun, kemudian pada saat itu memang belum menerapkan BIM. Nah, BIM ini yang diterapkan pada existing building ini menjadi membuat aset digital dari bangunan yang sudah ada, ya. Tentunya kembali lagi tujuannya untuk proses operasional, proses maintenance gitu. Bahkan BIM pada existing building misalnya digunakan untuk bangunan-bangunan heritage, ya, apa yang kita kenal sebagai heritage BIM, ya. Dengan begitu aset dari bangunan-bangunan tersebut bisa terekam dengan baik, bisa terdata dengan baik, lengkap dengan spesifikasinya, material dan sebagainya, gitu. Ini menurut saya lupa ininya, ya. Tapi BIM juga bukanlah perangkat lunak atau teknologi, tapi lebih merupakan metode dan proses kerja. Ini salah satu terminologinya, ya. Jadi ketika kita bicara BIM itu bukan hanya sekedar software, ya, tapi itu adalah sebuah metode kerja, ya, dan proses bekerja. Menurut Antonia Thor dari Building Smart, saat ini BIM bukan merupakan sebuah pilihan, tetapi itu adalah sebuah evolusi, ya, evolusi yang alamiah pada sebuah industri arsitektur, engineering, construction, and operation. Jadi ketika kita melihat saat ini sudah tidak bisa kita tolak lagi bahwa BIM itu adalah sebuah evolusi, sebuah evolusi dari proses kita membangun barangkali, ya, seperti itu. Nah, ini dari Bapak Nikodemus Daud, ini Direktur Kelembagaan dan Sumber Daya Konstruksi dari Dirjen Bina Konstruksi Kementerian PUPR, bahwa ketika BIM itu sudah melampaui tahap atau menjadi sebuah evolusi, ya, bahwa BIM ini menjadi sebuah budaya kerja. ya sebagai metode kerja, meningkatkan cara kerja dengan dengan koordinasi. Tanpa kolaborasi dan koordinasi, tentunya BIM ini tidak dapat dikatakan sebagai sebuah BIM yang baik gitu ya. Bahkan kalau dia bekerja sendiri itu kita katakan sebagai BIM alone gitu ya. Nah, kata kunci dari BIM ini adalah kembali lagi ketika informasinya dipertukarkan. Nah, di situ ada yang namanya kolaborasi dan koordinasi. Nah, ini beberapa terminologi saya kira kita perlu juga memahami supaya mindset kita itu tidak terbatas bahwa BIM itu adalah software, bahwa BIM itu adalah produk tertentu dari sebuah software, ya seperti itu. Nah, ini kira-kira sejarah perkembangan dari BIM ya. Kalau kita lihat dimulai dari tahun 70-an. Di sini sebentar saya coba munculkan ininya ya. Oke. Di sini dimulai dari tahun 70-an ya, konsep BIM ini pertama kali dimunculkan, lalu kemudian BIM sebagai terminologi BIM model ini oleh Simon Raffel dan Robert Hayes. Kemudian 87 ada satu software BIM pertama ya yang memang waktu itu disebut sebagai virtual building ya. Kemudian muncul terminologi building information modeling ini dalam papernya J.E. Van Nederveen dan F.P. Tolman ini tahun 92. Jadi kira-kira usianya sudah hampir 20 tahun ya. 30 tahun mungkin ya. Lalu di tahun 2001 ini pertama kali BIM masuk dan diperkenalkan di China. Ini. Kemudian akronim BIM ini muncul lagi oleh dari salah satu produk BIM juga. Ya. Lalu munculnya Integrated Project Model ini dan Virtual Building ini di tahun 2003. Jadi dia berubah dari namanya ya, hanya istilahnya sebetulnya, tapi kalau kita lihat metode kerjanya dari mulai BIM ini muncul itu tetap sama ya, dan terus semakin dikembangkan. Tahun 2007 ini BIM mulai diwajibkan di Amerika untuk proyek-proyek yang besar. Kemudian 2011 diperkenalkan di Inggris dan juga mulai diterapkan di China. Lalu 2012 ini diterapkan di Korea, Denmark, dan Belanda. Kemudian 2013 ini Singapura ini sudah mewajibkan ya penggunaan BIM dengan juga adanya e-submission bagi pada seluruh proyek bangunan baru dari 2013. 2016 dalam timeline-nya ini kira-kira BIM masuk ke Vietnam, Norway, dan Italia. Sementara di tahun 2017 ini mulai perkenalan dan adopsi penerapan BIM di Indonesia ya melalui kantor Kementerian PUPR. Kemudian ada di situ di Qatar, Jerman, Meksiko, Prancis, Skotlandia, dan Rusia. Jadi ini sejarah perkembangannya kira-kira seperti ini, dan saat ini sudah cukup banyak ya BIM teknologi BIM ini diadopsi di hampir seluruh dunia. Dan masing-masing area itu sudah membuat apa yang namanya protokol BIM-nya. Ya. Nah, Indonesia ini agak tertinggal gitu ya, agak terlambat begitu. Tetapi sebetulnya tidak terlambat sekali ya, karena teman-teman dari industri konstruksi sebetulnya jauh sebelum statement bahwa BIM itu digunakan di Indonesia. Teman-teman dari dari industri konstruksi ini sudah mulai menerapkan teknologi tersebut gitu dengan menggunakan standar protokol yang mereka adopsi dari paling dekat itu dari Singapura. Oke, ketika kita bicara BIM ini kita bicara juga tentang servicesnya atau layanan BIM-nya. Jadi BIM ini bukan semakin ke dimensinya semakin besar ya, dari 3 dimensi sampai 7 dimensi itu semakin tinggi levelnya ya, sebetulnya bukan seperti itu. Jadi jangan, mudah-mudahan tidak salah kaprah bahwa ini layanannya ya, mulai dari layanan 3 dimensi yang kaitannya terhadap modeling, kemudian BIM 4 dimensi atau dimensi keempatnya ini terkait dengan project schedule ya, kemudian cost itu di dimensi kelima, Kemudian di dimensi ke-6 ini building performance, ya salah satunya ada istilahnya misalnya di situ green building, kemudian ada entity analysis, kemudian simulasi yang berkaitan dengan performa bangunan ya, struktur, misalnya evakuasi, itu sebetulnya bisa kita katakan sebagai performa bangunan di sana. Dan dimensi ke-7 ini adalah bagian layanan BAM yang berkaitan dengan building life cycle, misalnya kemudian dia sebagai BIM sebagai data ya, sebagai informasi untuk proses misalnya maintenance, kemudian di situ ada juga untuk cost operation. Misalnya data itu dimanfaatkan juga misalnya data space-nya itu dimanfaatkan untuk bagian penjualan dan sebagainya. Jadi kita lihat seperti ini. Kalau dilihat dari dari lingkupnya, ya 3 dimensi dan 4 dimensi ini umumnya di bagian pra-design, schematic design sampai ke development design. Kemudian 5 dimensi ini masuk ke construction. Ya, sebetulnya 6 dimensi ini juga bisa bagian dari simulasi-simulasi awal di bagian schematic design. Lalu kemudian yang 7 dimensi ini kaitannya dengan as-built drawing. Lalu setelah tahun 2017 itu pemerintah mulai mengambil langkah strategis, gitu ya. Nah, kalau kita lihat di sini ada 3 peran utama yang terlibat di sana. Ada peran pemerintah, kemudian peran masyarakat industri konstruksi, dan peran dari institusi pendidikan. Pemerintah sendiri diawali dengan membangun roadmap, ya roadmap BIM di Indonesia. Kemudian membuat regulasi-regulasi yang berkaitan dengan penerapan BIM. Ya, kemudian nanti di situ ada masyarakat industri konstruksi dan sekolah. Nanti kita coba lihat satu-satu. Nah, di sini langkah strategis pertama dengan munculnya peraturan yang dikeluarkan oleh Kementerian BIM, beberapa pekerjaan dioptimalkan menggunakan BIM agar lebih mudah dan terorganisir. Jadi diawali dengan tahun 2018 itu pemerintah mengeluarkan apa yang namanya sebentar di sini. Nah, ini roadmap-nya, ya, dari 2017, itu pemerintah membuat roadmap seperti ini. Ini dokumen ini saya ambil dari Direktorat Kelembagaan dan Sumber Daya Konstruksi tahun 2021. Itu mulai menginisiasi ya bagaimana pemahaman stakeholder tentang BIM ini, gitu ya. Mulai mengumpulkan atau mulai membahas ya bagaimana standar-standar, protokol, kemudian regulasi, kemudian pilot project, dan seterusnya. Kemudian di tahun 2019 ini proses digitalisasi, di sini penguatan dari infrastrukturnya, kemudian beberapa juga sudah mulai mencoba menerapkan teknologi ini, gitu ya, teknologi BIM ini dalam proses konstruksi. Lalu di tahun 2021 ini membuat standar kolaborasi, jadi yang sebelumnya barangkali masih belum terpadu di kementerian, di tahun 2001 ini sudah disiapkan ya beberapa platform untuk mengintegrasikan BIM ini melalui e-submission. Di situ kalau dari pemerintah itu memiliki apa yang namanya SIM bangunan gedung, beberapa SIM lah gitu, sesuai dengan prinsip-prinsip yang diterapkan dalam protokol BIM. Nah, di sini terobosan dalam menjawab tantangan dan permasalahan BIM. Kalau di sini ada 5 terobosan, diantaranya regulasi hukum, sumber daya manusia, pendanaan inovatif, kepemimpinan dan penerapan hasil riset dan teknologi. Jadi di bagian kelima inilah BIM ini hasil-hasil riset tentang BIM ini mulai diterapkan di dalam proyek-proyek pemerintah. Lalu di Indonesia juga membentuk apa yang namanya divisi ya BIM di dalam Kementerian PUPR. Jadi sekarang sudah ada divisi khusus tentang BIM di PUPR. Nah, divisi inilah atau bagian inilah yang mengawal gitu ya. Terkait dengan penerapan regulasi dan sebagainya terkait dengan BIM di Indonesia. Nah, di sini proses adopsi ini perlu diperkuat dengan serangkaian kebijakan, ya. Pertama, pemahaman BIM bagi owner, ya. Jadi bahwa BIM ini tidak hanya untuk satu pihak gitu ya. Jadi bukan hanya untuk perencana, bukan hanya untuk pelaksana, tapi juga bagi owner gitu ya. Agar memiliki kompetensi yang memadai serta istilahnya penyusunan standar protokol BIM sebagai referensi dalam menyiapkan paket-paket pekerjaan BIM ini. Kalau kita kaitkannya dengan owner sebagai PUPR sebagai owner, membuat dokumen standar ya yang sesuai. Nah ini juga masih saat ini dokumen KAK umumnya masih belum seragam semua. Kemudian mensyaratkan KAK ya agar konsultan perencana menyerahkan BIM file BIM ya, dan seterusnya. Kemudian mempercepat proses edukasi. Nah disinilah peran institusi pendidikan ya dalam mempersiapkan sumber daya manusianya terkait dengan penguasaan teknologi building information modeling. Lalu ada satu yang menarik adalah mendorong penggunaan open BIM di sini agar tidak terpaku pada satu produk tertentu gitu ya, seperti itu. Kemudian adanya kampanye stop penggunaan lisensi bajakan ya. Nah, ini juga penting sekali dan seterusnya. Kemudian dari peraturan Menteri nomor 22 tahun 2018 ini juga sudah ada kewajiban BIM untuk bangunan di atas 2000 meter persegi ya, terkait dengan produk yang harus dihasilkan. Lalu juga ada peraturan-peraturan lain yang mengawal penerapan BIM dan mempertegas gitu ya. Di sini dengan dikeluarkannya peraturan pemerintah nomor 16 tahun 2021 yang sebagai peraturan pelaksanaan dari Undang-Undang tahun 2002. Kalau kita lihat di sini sudah menstatementkan lebih detail lagi untuk proyek-proyek tertentu. Di sini proyek dengan padat teknologi ya, salah satunya wajib menggunakan BIM paling sedikit sampai dimensi kelima, artinya sampai ke perhitungan cost ya. Kemudian dengan padat modal, di sini wajib sampai ke dimensi ke-8. Wah, di pemerintah lebih keras lagi di sini sampai ke dimensi ke-8. Sementara tadi kita lihat di awal BIM hanya sampai ke dimensi ke-7. Lalu juga adanya surat edaran dari BIM Bina Marga ini untuk teman-teman dari bidang jalan ya, jalan dan jembatan. Ini juga sudah ada edarannya di mana wajib menggunakan teknologi ini. Nah, ini kira-kira tambahan sedikit dari dimensi ke-8 versi kementerian gitu ya. Jadi memang agak berbeda sedikit, tetapi pada umumnya mulai dari 3 dimensi, kemudian 4 dimensi, 5 dimensi ini kaitannya dengan cost, ya, 6 dimensi ini kaitannya dengan energy, 7 dimensi ini kaitannya dengan sustainable. Ya, di sini kaitannya dengan building life cycles-nya, kemudian maintenance ya. Ini bagaimana bangunan itu ketika dioperasionalkan itu hemat energi gitu ya, lebih ke sana sebetulnya. Nah, dimensi ke-8 ini kaitannya dengan safety ya, keamanan dan keselamatan kerja gitu di sana. Bagaimana dalam proses BIM ini sudah mengaitkan dengan rencana emergensinya ya, atau juga rencana antisipasi ya terhadap isu-isu keamanan gitu dalam pelaksanaan. Jadi dari versi pemerintah ini sampai seperti ini. Nah, lalu ada peran pemerintah, masyarakat, industri konstruksi dan institusi pendidikan. Coba kita lihat di sini. Salah satu langkah strategisnya ini teman-teman dari komunitas sebetulnya ya, yang mewujudkan terbentuknya apa yang namanya Institut BIM Indonesia. Di sini ya mencoba membantu merumuskan atau mengusulkan apa yang namanya protokol BIM, peraturan ya terkait dengan pelaksanaan penggunaan BIM baik dari level atau dari bidang konsultan sampai ke pelaksanaan. Ya, di sini mendorong implementasi BIM di pemerintah dan sektor private, ya, membangun standar-standar, membangun kompetensi BIM-nya, membangun database-nya, ya, dan mendorong penelitian-penelitian terkait BIM di lingkungan akademis. Jadi ini peran Institut BIM Indonesia. Kemudian peran masyarakat industri ini kalau kita lihat cukup banyak sebetulnya perusahaan-perusahaan BUMN dan swasta yang sudah menerapkan teknologi ini lebih awal gitu sebetulnya. Kaitannya dengan bagaimana mereka bisa mempercepat pelaksanaan proyek sesuai tenggat waktu yang disediakan gitu ya. Dimana pada saat bersamaan itu juga berlangsung pekerjaan-pekerjaan lain gitu, sehingga mau tidak mau menerapkan teknologi ini menjadi suatu keharusan. Nah, tadi ada peran pemerintah, peran masyarakat industri konstruksi ya, komunitas ini dalam rangka untuk mempersiapkan protokol BIM seperti ini ya. Saat ini sebetulnya sudah ada tahun 2020 kemarin. Ini disusun dengan maksud untuk mendukung percepatan pembangunan infrastruktur dengan meningkatkan kualitas pekerjaan konstruksi melalui penyeragaman prosedur. Ya, jadi supaya sama semua seragam gitu, standarnya sama, ya. Kemudian data-datanya itu yang dipertukarkan dengan protokol atau dengan cara komunikasinya yang sama gitu. Namun tentunya dengan software yang berbeda, itu tidak jadi masalah. Jadi dengan protokol ini diharapkan implementasi BIM di Indonesia tidak menjadi suatu kendala. Nah, langkah strategis yang lain ini kalau kita kaitkan dengan institusi pendidikan, ini tahun 2018 juga, ini sudah ada yang namanya nomenklatur perubahan struktur kurikulum di sekolah menengah kejuruan. Jadi di sini ada kompetensi keahlian yang namanya dulu gambar bangunan ya kalau nggak salah, di tahun 2018 ini dirubah menjadi desain pemodelan dan informasi bangunan atau DPIB ya. Nah ini salah satu langkah juga untuk mendukung penyiapan sumber daya manusia terkait dengan modeling ya, tenaga operasional dan modeling BIM ya. Lalu ya, pemerintah juga dengan perguruan tinggi ini mengadakan workshop-workshop untuk meningkatkan kompetensi baik dari sisi ASN-nya maupun dari sisi tenaga profesionalnya ya, yang tersebar di seluruh Indonesia. Itu sampai tahun 2020 kemarin ini masih berlangsung gitu. Jadi banyak sekali kampus-kampus yang terlibat, pertama menjadi trainer, kemudian setelah menjadi trainer, kampus-kampus tersebut wajib memberikan training kepada masyarakat industri konstruksi yang ada di daerah masing-masing. Ya.
Waktunya.
Oke, how much?
Last minute.
Oh, oke. Saya percepat saja. Jadi ini kira-kira pencapaian pekerjaan BIM di Indonesia dari Direktorat Sumber Daya Air. Saya kira ini saya juga mengutip dari Direktorat Bina Teknik. Ya, jadi banyak sekali ternyata yang sudah menggunakan BIM. Lalu dari Direktorat Cipta Karya ini yang terakhir itu adalah pembangunan Stadion Istora Papua Bangkit di Papua, dan saya kira masih banyak yang lain gitu ya. Untuk terkait dengan jalan dan jembatan ini, kalau kita lihat jalan-jalan di Jakarta ini rata-rata dari teman-teman BUMN sudah melaksanakan pembangunan menggunakan BIM. Nah, bahwa penerapan BIM ini harus dimulai dari semua fase, dari awal perencanaan hingga pelaksanaan. Jadi semua fase itu harus menggunakan BIM supaya proyek itu mendapatkan keuntungan dari penerapan BIM-nya, terutama dari efisiensi di sana. Ya, dari satu siklus ini, yang mulai dari perencanaan sampai operasional, sampai bangunan itu mungkin direnovasi atau didemolis. Ya, ini kalau dilihat, ini kira-kira di mana peran dari masing-masing pihak gitu ya terhadap dimensi BIM. Ya, 1, 2, 3 ini untuk konsultan ya, biasanya di sana, atau sedikit juga di 4 dimensi ini bagian dari konsultan. Tetapi ketika masuk ke 5 dimensi, 6 dimensi dan 7 dimensi ini bagian dari teman-teman kontraktor barangkali ya. Jadi kira-kira lingkupnya sampai ke sana. Nah, ini dukungan vendor perangkat digital, ini sudah banyak sekali ya software-software yang bisa digunakan sesuai dengan lingkup pekerjaan masing-masing gitu. Terkait dengan BIM ya, dari modelingnya bahkan sampai proses maintenance bangunannya itu bisa didukung dengan software tertentu. Nah, ini salah satu software yang berkaitan dengan 4 dimensi dan 5 dimensi dalam project management. Jadi datanya itu adalah data model 3 dimensi yang dimasukkan, kemudian diambilkan, diresumekan informasi terkait volume dan sebagainya. Lalu kemudian disusunlah rancangan cost-nya, biaya, dan rancangan schedule pelaksanaan pekerjaannya. Nah, ini salah satu barangkali yang kaitannya dengan tim untuk infrastruktur jalan ya. Nanti ini yang disampaikan oleh teman-teman dari FORUM8 ya. UC Wind Road salah satunya. Kemudian, nah perangkat-perangkat hardware yang lain kita sudah ketahui bahwa dukungan drone untuk pengambilan data lapangan itu sudah sangat umum sekarang digunakan. Kemudian adanya virtual reality sampai teknologi imersif ini sudah sangat masif digunakan, terutama berkaitan dengan inspeksi di lapangan. Ini saya kira menjadi satu hal yang sangat penting ya, demi terjalinnya atau terwujudnya proses BIM yang dilaksanakan dari mulai perencanaan sampai ke pelaksanaan. Yang ini kemampuan perangkat keras ini menjadi satu isu yang penting buat kita di Indonesia. Perangkat atau software BIM modern saat ini umumnya sangat besar ya, sangat banyak atau sangat membutuhkan spek yang cukup tinggi. Nah, salah satunya itu mungkin saya munculkan di gambar ini aja. Nah, jadi ketika ini saya punya ada satu kasus pekerjaan seperti ini ya, kita melaksanakan sebuah perencanaan pada sebuah kawasan yang cukup besar, memadukan antara infrastruktur jalan, bendungan ya, dan rencana landscape. Ini kebetulan baru pada saat tahap perencanaan. Jadi perencanaan yang dibuat terpisah-pisah kemudian disatukan. Siapa yang membuat rencana jalan, siapa yang membuat rencana bendungan, ini begitu diiriskan dalam satu wadah bersama ya, kami menggunakan cloud. Nah, di sini terlihat bagaimana sebuah sistem jalan itu memotong pada rencana landscape yang dibuat, memotong pada rencana bendungan yang dibuat, memotong pada rencana jalan inspeksi yang dibuat gitu. Nah, ini menjadi satu kasus yang menarik sebetulnya ketika ini kita bisa laksanakan pada tahap perencanaan. Tentunya pelaksanaan nantinya pada saat pelaksanaan kondisi-kondisi ini bisa lebih mudah atau lebih sudah terhindari dari sejak awal gitu, perencanaan seperti ini. Namun yang menjadi persoalan itu adalah dalam prosesnya ini resource komputer atau komputer yang saya gunakan ini habis gitu. Nah, ini isu yang menjadi isu menarik juga gitu ya, bahwa kehadiran software-software modern tentunya sangat harus dibarengi dengan peningkatan juga dari kemampuan hardware yang dimiliki gitu. Nah, ini sekedar contoh saja bahwa ketika kita menerapkan BIM dalam sebuah project, ini contohnya ini lebih luas lagi, bukan hanya bangunan, ini infrastruktur yang luas pada sebuah kawasan, resource komputernya. Kemudian hal menariknya adalah kita bisa secara awal atau dari awal sudah bisa mengetahui terjadinya clash detection seperti ini ya, terjadinya tabrakan antara rencana yang dibuat oleh pihak lain ke dalam satu wadah bersama gitu untuk dikolaborasikan. Nah, ini salah satu kunci keberhasilan dari proyek berbasis BIM. Kita berdarah-darah di awal ya, pada saat perencanaan kita bentroknya di awal, tetapi pada saat pelaksanaan persoalan-persoalan ini sudah jauh lebih terselesaikan gitu. Barangkali itu yang bisa disampaikan. Ini beberapa pustaka yang saya jadikan referensi ya. Ada sebetulnya masih ada yang lain, tapi ini yang masih yang sudah bisa saya tuliskan. Oke, terima kasih. Barangkali lebih mungkin 5 menit ya presentasinya. Saya kembalikan ke moderator Miss Tias.
Thank you Prof. Erwin for your presentation, very insightful, sangat insightful sekali untuk kita semua. Saya sebelumnya mau mempersilahkan dan mau memberikan welcome untuk partisipan yang baru saja hadir. Terima kasih sudah hadir. Setelah ini akan ada pemaparan terkait dengan VR/CG Seminar dari Mr. William Nelson. Perlu diketahui bahwa nanti Mr. William akan menyampaikan seminarnya dalam bahasa Inggris. Buat partisipan yang baru saja hadir, mungkin dari layar Zoom Anda di sebelah kanan itu ada globe icon atau icon berupa bola dunia. Buat yang mau memilih bahasa yang dikehendaki untuk didengar, silahkan mungkin bisa memilih bahasa Inggris atau Indonesia. Untuk Q&A session nanti akan kita adakan di akhir ya. Baik, setelah ini saya akan mempersilahkan Mr. William. So, Mr. William, are you ready? This time is your turn, so please.
Okay. Thank you very much, Professor Irwin, for your presentation. It was very insightful, and we are very glad to have you join us for today's seminar. If you have any questions, again, please ask them at the end during our Q&A session, so that we can get those questions answered, and if you're interested in any of this software. Okay. Okay, so now we will start the FORUM8 presentations here. We have 3 presentations in total, as mentioned in the agenda at the beginning. For the first presentation, we will do our VRCG seminar here. For the second one, it'll be the UC1 FEM seminar. And for the last presentation, we'll do the Iem and VR presentations. Okay, and what we want to do is, for this first presentation, I'm going to introduce 2 of our softwares. This will be VR Design Studio and Shade 3D. Just to help avoid any confusion, VR Design Studio and UC WinRoad are the same software. VR Design Studio is the name that we use internationally, and UC WinRoad is the name that we use in Japan. So I may accidentally use either name interchangeably. So please understand that VR Design Studio and UC WinRoad are the same software. Okay, now that's out of the way, what is VR Design Studio UC WinRoad? So that is this. So this is VR Design Studio. And what we attempt to do, that might be pretty loud there. So let me lower that. This one, there it is. Okay, so what VR Design Studio UC WinRoad aims to achieve is provide a real-time visualization interpretation of your project in a really highly accurate environment. And what this allows you to do is see the big picture of your project, of your, maybe if you're building a small new bridge or location, you can see just what that kind of bridge would look like in its environment. And what we're looking to achieve is to have this really extensive platform system. So by building on the foundation of VR Design Studio, we want you to be able to customize and build your projects in any way that you see fit. And this software enables you to visualize your project. Let me get this out of the way, it might be blocking here. There we go. And so we have full GPS support. So this right here is the Shibuya Scramble. If you're familiar with Japan, you may have seen this in a couple of YouTube videos or something, where you have the most popular intersection in Tokyo, and it's probably one of the most busiest intersections in amount of foot traffic. And so we've recreated the Shibuya Scramble, the Shibuya intersection, in VR Design Studio, and that is what we have here. And what we can do is we can look down here in the bottom left, we can see the GPS coordinates and understand that these are the real world GPS coordinates, latitude and longitude of Shibuya Square. And with the real world GPS coordinates, it comes with real day and nighttime cycles. So we have our little clock here in the top, we can change our time, and we can really understand and visualize Shibuya Scramble in, you know, any time of day. We can go into the nighttime here. And when we go into the night, what we need to do is turn on our advanced lighting system here so that we get our headlights and our street lights and everything going at the same time here. Okay. And now we'll go back into the daytime, the daytime there. And while it's really good for visualizations, it's also, VR Design Studio really prides itself on its interaction. So what we can do is we can simply, you know, click on a car here and we can go for a quick ride. As you can see, I'm sitting here in the passenger seat of our kind of fully modeled interior. And again, this is just a default modeled car that we have implemented for testing purposes. If you have a specific car, you can ride along in, your custom model or anything like that. What I can then do is then press the enter key, and then I can take control of the vehicle. I switch over to the driver's seat, and now I'm in control. I'm only using the arrow keys on my keyboard, so forgive my bad driving, but what you can do is connect a controller or a drive simulator, which we have a lineup of, and really get immersed into your visualizations and your projects. Okay, and let me hop back over here. And of course, we also offer multiple views. So if you have a larger drive simulator, you can get the kind of full immersion of it. And we have also full support for VR headsets and VR displays. So if you wanted to actually, fully immerse yourself into the environment, you are free to do so. Okay, now you might be thinking, wow, this seems like it's pretty heavy, William. How can we control all this with just a couple of clicks? Well, it's actually not that bad. VR Design Studio is made so it's broken down into 4 main steps. So that, let me turn down that. Forgot to turn that off, so that's going to keep running in the background. There we go. VR Design Studio is broken down into kind of 4 main steps here, and this allows for any kind of users to really grasp what VR Design Studio aims to achieve, and just really get down into their simulation and what they want to simulate as quick as possible. So these 4 steps are surface input, which is the terrain generation and the terrain import. And then on top of that local terrain, then you design or you define your roads, the alignment, the sections, where your intersections are, where current intersections are, or where you would like to plan future intersections. And then on top of those road definitions, then you design the road itself according to the parameters set by you. So if you have specific curb heights, or if you have a specific color for your crosswalks, that can all be customized within the road generation and traffic flow generation. And then on top of all this, then we have our final visual option tools. So you run into your weather options, your sky, cloud, and terrain options, specific vehicle modeling, vehicle materials, and all that is then placed on top of the analytics and data part of VR Design Studio. And well, this is all a lot of text, and just to kind of give you another quick demo of what this looks like, I've downloaded the area here within Shinagawa, which is in Tokyo, where our current office is right here, or just about here in this little building right here. But this is the basic terrain, and I've pasted a satellite imagery of it so that we can get a kind of better understanding of what we're looking at. And then what we can do with this terrain is we can then build on top of this. And there's multiple ways for doing this. We can go through and build each building piece by piece, but that doesn't really make much sense in terms of efficiency and the time it takes to get to the simulation, which is really what people want to do, would take ages. So we've implemented a lot of tools to help our engineers and construction consultants to help them get to their simulation as quick as possible. What we're really recently been doing is working with a lot of open data. So a lot of companies, a lot of governments have recently been pushing for the modeling and 3D modeling and laser scanning of their local cities and towns. And Japan is one of those governments. They've developed this plateau system, which offers open 3D modeling and open 3D laser scans of their local environments. And if you notice, this is the same Shinagawa environment as I've downloaded here. But this time it has all the buildings. And you can see some of these buildings have highly accurate texture detail. This tall building that's kind of shaped like an oval is the FORUM8 head office. We're about here on just about, whoop, a little too much, about here on the 21st floor here. That's where we're sitting now. And what we can do with these models is we can take this open data and import it into UC WinRoad. And while we're constantly upgrading and improving the textures, and while downloading all these high quality textures will take quite a long time, let's just stick with the white box data that we have. So Plateau is one of the open source data provided in Japan. And another one that you may be familiar with is OpenStreetMap. And that is also implemented within UC WinRoad. So let me back up a little bit here. Go into our edit settings here, zone editing, and then download features. And then what I can do is I can just select what area I want to download for my features. Press enter. Well, you don't need any forests. We're only going to get buildings, and I'll download straight from OpenStreetMap. And as you'll see, once the download completes, and there we go. And we'll hit OK, confirm, and now we've got our gray box buildings, just like we saw in the previous one. We can zoom in just a little bit here. Oh, not too much. And there we have our kind of oval building of the Tokyo head office pasted on top of our satellite imagery. And this will help us get a visualization of where our projects are. And of course, all of these buildings here, like I mentioned before, are latitude and longitude accurate. So these have the correct GPS coordinates according to their location in the real world. So you can be sure when you're working on your project that you're not just working in a fantasy land, you're working with real world objects. So now we've got our base models and an idea of what we want to draw. Let's make an intersection. We can do a quick road here. We can have this open lane here and this open lane here. We go into our plan view, and what we can do is just go right into our easy to use system. And you can see we've got our models drawn here on our map, and we can just simply hit make a road. We'll draw a couple lines here, make it turn, make that there, finish that up, and fix it up. And then we go into our second one here, and just a couple clicks, finish the road, fix it if there's any errors, because there might be some terrain generation errors or clipping, and the system will automatically fix it. Then we'll go into editing, and this is our terrain visualization of the road that we just built. The gray area here is the ground, and the white area is the sky. So if we build a road, way up into the air, we'll have to, make it a bridge, which can be easily done with our add bridge feature. Or if we do it deeper into the ground, we would have to do a tunnel, which can also be easily done with our add tunnel feature. But for now, we'll just make a simple road on top of the terrain with a little bit of a banking to make sure that it matches. This green dot here is the first road that we made. And as long as these roads are overlapping at the same point, the intersection will automatically be generated there. So now we've got our roads generated here, and we can go ahead and hit OK. And there we go. We've got our first two roads with an automatic intersection here. And you can see the road markings are already there. I forgot to explain that real quick. Within each of these roads, we have our road sections here down at the bottom. And what we can do is we can really define what sections we have. We have a default 6-lane highway road set here. But if we wanted to create a new design, we just simply hit in section type road, design new. And then right here, we can then design what kind of road we want to see. We can edit almost every aspect. Well, we can edit every single aspect of this road, the type of the guardrail, the texture of the guardrail, the length of the lines, everything can be designed and edited to meet your standards, right? And okay. And of course, this also applies to the bridge design and the tunnel design as well. So if you have a specific tunnel design or a specific bridge design, that can also be edited. we also have specific designs for cutting and baking design as well. But I'll get more into that in my Iem and VR. Right now, I'm just giving a quick basic introduction to UC Winroad. Okay, so now that we've got that done, hopefully that will finish there, not get stuck in that loop. And there we go. So we've got our two roads here, and it's a little bit off the ground here, so you can see the banking that has automatically been generated here. And now that we've got our intersection, we can go right into kind of what kind of design we want for the intersection if we had a specific design we're looking for. But we also have a quick automatic generator here that we can just quickly edit, and it will automatically determine the drive paths for the road and where the stopping points are for the road. And if we wanted to implement stoplights, we can do so as well, but we can save that for another time. Next, we want to put vehicles. This road's a little bit lonely, so we go into our traffic generator here. If we want to do a specific type of kind of profile, we can do so. If we go right into our profile here, we can edit it and choose what kind of vehicles we want to appear on this road. Everything is assigned a proportion here. So we have, coupes, small cars, bikes, SUVs, and trucks, all set to a specific proportion. But maybe if you have a truck-heavy highway, you can change the proportion of trucks, or if you have a bike-heavy environment, you can really bump up the number of bikes as well. So we'll hit OK, and next we'll close that up, and let's add a couple more. 500 cars per hour seems a little small, so what we can do is we can make it 1,500 cars per hour. Close that up and start our traffic simulation. And now, since every vehicle starts at the end of the road, I'm going to advance time just 10 minutes or a few minutes ahead and stop. And now we've got all of our vehicles within our environment here. And at any point, we can just simply choose a car that we want, hop in the driver's seat, and go for a ride. And take it for a drive and go right into the roads. And this is the basics kind of what UC Winroad is focused on. VR Design Studio, and how we can use it to begin designing our projects and begin designing our environments. So let me go ahead and stop this. We'll go back to the slides for a minute. I mentioned that it's also for interaction and for drive simulation as well. And at the beginning of the introduction, I also introduced the safe driving simulator that we have. This is a stationary simulator that allows students to experience various scenarios within UC Winroad. You can design specific, maybe dangerous environments or dangerous situations, or maybe you're driving through the rain or driving through the snow. This can all be simulated within the safe driving simulator, and then the student can then practice driving in those environments. And while the student is practicing, they will also get a live feedback report on how their driving is doing. The instructor can also sit behind them as well, so that they get real-time feedback and understanding of how they're performing, all while being in a safe simulation environment. This also helps get them used to the real-world vehicle controls with the real-world, a real vehicle steering wheel and the actual pedals and brakes from a car as well. So you kind of get the familiarity of being in a vehicle while also being safe in a simulation environment. And it's not just the safe driving simulator that we have. We have operated in many different levels of freedom. We call them degrees of freedom. So all the way from the 0 degrees of freedom, like our safe driving simulator, all the way up until 8 degrees of freedom. And this is the massive simulator that we've worked with in the past. And I've got a quick video here to show you that this is the 8 degrees of freedom simulator that we use. And within this simulator itself, we actually have a full vehicle inside of it. So you have the full immersion while you're driving through this simulation. And again, the scenario is driving up a foggy mountain road or driving through the rain. It can be really customized to meet your needs. And then this feedback report Along with inside this simulator, there's a lot of numerous cameras and tracking equipment to ensure that every piece of data that is gathered inside that simulator is analyzed properly in an environment. You can see the mirrors as well, all working effectively as well. Very, very cool simulator, and I always wanted to drive in it as well. Okay, so I talked a little bit about Design Festival 2020 at the introduction, but now I'd like to introduce some of the case studies that have been introduced in the VR simulation contest. So we had our 19th 3D VR simulation contest, and our grand prize winner, our Grand Prix winner, sorry, was the construction VR simulation during a bridge repair system. And that didn't work. Okay, and then we'll go right here onto our homepage if you want to look for yourself, and you can access, actually, let me go to the English homepage here. So if you go to the FORUM8 homepage, you can click on this Japan English page, and that will take you to our English website. And you can visit and see these works for yourself. And then we have here, this is the bridge repair movie that we have. And as you can see, it's just, we have a bridge, and what they designed was every single step of the process of this bridge repair. And what this allows is any stakeholder involved in this repair can easily and quickly understand what's the step that we should be on, what's the next step that we're working towards, and okay, can you hear me now? Okay, I apologize for some technical difficulties with my microphone, but now you can hear me. So as I mentioned, every step of this bridge repair is explained through this video and the simulation that was created utilizing using VR Design Studio, so that everyone can understand what part of the project that they are on and what's the next project that they will be on. Very interactive system, and we're very happy to be a part of it. And we were very proud of what this company was able to achieve with it. The next one was the simulator for remote control training for heavy machinery. In Japan, that's pretty loud. In Japan, just a couple months ago, we had about a huge amount of rainfall that came through the mountains and caused some pretty dangerous landslides. And when those landslides occur, the debris that happens is quite enormous. And when you need to clear that debris, you need to use some heavy machinery to get rid of that. But bringing in the heavy machinery onto that soft soil can be quite dangerous. It's even dangerous for the operators. So what we're working with this company and what they've simulated within VR Design Studio is this remote control project. So that utilizing a remote control to control this heavy machinery and go into dangerous environments to help clear that debris while keeping the operators and those individuals safe from any danger as well. Okay, and the last one that we will talk about today is the reaction driving test from DINSO. This was a project utilizing the drive simulation aspect, and for some reason that video isn't loading. Okay, well, that video didn't load. But what it is you probably saw it in this video here, where we have the individual driving through their environment, and sudden reaction test will occur. So perhaps a bicycle will jump out from an unseen location, and then testing the speed and reaction of the individual as they're driving through their environment. So from a blind spot, a bicycle comes out. If they hit it, if they stop in time, and that will all be measured based on the driver's ability as well. It's a set course within a square grid, and as they're driving, there will be various different unexpected events occurring as well. Okay, so back to my PowerPoint here. We talked about these here. And okay, Next, I want to introduce some of our student programs that we have. We have two. We have the Cloud Programming World Cup and the Virtual Design World Cup. That is actually cut off there. Okay. So the Cloud Programming World Cup is a student focused project that allows students to practice their programming skills and understanding how they can utilize our software to better their designs. It is a free entry for student groups, but it also comes with cash prizes if their teams are awarded. The cash prize for the top rank is about 300,000 yen, which is 3,000 US dollars. And the second to fifth place awards are 50,000 yen, which is about 500 US dollars, with some trophies and certificates as well. The first winner was Driver. This was the Korean team focused on programming and designing a eye tracking software system here. And let me go here and pull that up for you, day 2. And then we've got Cloud Programming World Cup, and we've got the information for that is, ooh, okay, well, give me 1 second here. Pull that up. I don't think that'll be here. Here we go. So here we go, CPWC, and then we had our past winning awards. And, well, okay, so I don't have the video available right now, unfortunately, but their project was focused on utilizing eye tracking technology as the driver was moving through their environments and driving through their system. And they designed it utilizing a car in a garage with hooked up to the UC Road simulation system, and the driver wore a pair of glasses. And as the driver was looking various different areas, they designed the object detection system within UC Road to identify what the driver was looking at. And then if that determined to be dangerous, then it would flash a warning to the driver that they were driving in dangerously and they needed to pay attention. It was very, very intuitive system, and we are very looking forward to seeing what they come up with next. Okay, since I don't have those videos working, we'll just kind of move on a little bit here. Okay, so since those are not working there, I'm just going to kind of skip ahead here and mention that we are doing another design festival. We have it every year. This year's will be November 17th to the 19th. We would really, really appreciate if you would come out to participate in the event. Again, it is free to participate. This year and last year, it was determined to be a hybrid event. And what that means is that we have the event here in Japan in our Tokyo office, or sorry, near our Tokyo office, and we also have it online in our kind of online system that we've been working with. Last year we used spatial chat to kind of bring together everybody and to have a kind of more intimate environment. But this year I believe we'll use various tools to make sure that everyone is enjoying their time. We would really appreciate your application, and please reach out to us if you're interested as well. Oh, let me go to the next slide. Again, we also have our CPWC Cloud Programming World Cup and Virtual Design World Cup events going on for our students. Unfortunately, the deadlines have passed back in June, but again, if you wanted to participate, or if you're a student group looking to participate, we would be more than happy to have you. All you would need to do is, first, you can attend this year's design festival, see how things are set up, see the projects that are winning this year, and then you can be able to enter into next year's event. Entries usually start around the beginning of April of the year, okay? So we are looking forward to your applications as well. And lastly, I'd like to introduce our all-in-one 3D CG software, Shade 3D. If you've used other 3D CG software, you'll be very familiar with the kind of interface that comes with this software. But one thing that really sets Shade 3D apart is its all-in-one functionality. And what this allows us to do is really interact and create a lot of different environments or models that can be then used within the FORUM8 software family. And of course, it can also be exported into other software as well. We offer two base modeling systems. So we have the CG computer graphics modeling or the CAD modeling system built within Shade 3D that can easily be changed in and out. And then within these systems, we can easily design various different objects, or if we had different designs. And then you can see in a live preview of the rendering and things, kind of objects like that. We also offer a full database of objects available called the Shade Explorer. Within Shade Explorer, you can pull in different objects that we have prepared for default objects and for testing and understanding how Shade 3D works. We also offer a 2D view, which I'll talk a little bit later during my Iem and VR presentation, but it's just really to help any kind of designer looking to get more out of their visualizations and presenting their projects to the relevant parties. Also, Shade 3D, one last little bit, it offers a free 3D printing assistant that comes with the software. So if you're looking to 3D print your model, you can check to see and run various checks to see if it is 3D printing compatible, fix those errors automatically, and then print your object with ease. Okay. And as with all of our software, it is being updated constantly. And with Shade 3D version 21, we've implemented that 2D drawing view that I mentioned, added some more material support and real-time functions as well. And for the sake of time, I'll just kind of skip ahead here a little bit. For Shade 3D, we also do offer the Hdr Display so that you can quickly and easily understand your HDR, your model in various different lighting conditions as well. Okay, and we also offer the real-time shadow display and our real-time preview rendering function as well. And you can choose the various locations of the lighting source with ease. Okay, and in recent updates, we've also included the BIM Sim design check option. Unfortunately, the standards are only set towards the Japanese standards at the moment, but we are looking to expand the BIM Sim checks for international standards as well. Okay, we also offer full support for IFC files, which is becoming a growing standard for BIM tools as well. All right. So first, that concludes my first presentation here with the VR CG environment. Thank you very much for listening. And next, I will hand it over to my colleague, Hinako Kyotani-san, for the next presentation.
Thank you so much for the introduction. My name is Hinako. I am a member of the International Cyber Sales team. I will be taking over from here to talk about our products. Let me set up the screen. So I will be talking about our product, UC1 and FEM products. This part of the seminar consists of two sections. The first section is about the functions of the UC1 series, Geoengineers Studio, and Geotechnical Analysis products. The second part is about the analysis and technical services regarding these softwares and the example usage provided by our clients that won NARDA prize. So we will be looking at the products, functions of UC1 series, Geoengineers Studio, and Geotechnical Analysis products from here. But before that, I would like to explain national resilience. We have this plan established by the Japanese government. It is called national resilience. As one of the most disaster-prone countries, we need to enhance infrastructure to prepare against disasters and mitigate damages resulting from disasters. This includes building an infrastructure urban planning, transportation, land improvements, equipment, and the environment to allow these changes. We have various products to support these changes in these 5 different areas. Many of our products cover wide ranges. For example, as William already explained, VR Design Studio, UC Ring Road, and VR Clouds provide the virtual reality environment that allows different types of simulations. In this part of the presentation, we'll be focusing on the software at the bottom of the screen here, the FEM analysis application called Engineer Studio, this one, and civil engineering design software series called UC1. Overall, our products provide solutions for the national resilience, which lead to the safety of people's lives. So, UC1 is the civil engineering design software series. UC1 series include various choices of design software, depending on the types of the structures you wish to create. For the seamless data exchange among these design, modeling, and VR software, we have this system called 3D Parametric Tool. 3D Parametric Tool allows easy 3D model creation of the structure, efficient design operation from preliminary design to detailed design by data linkage. And moreover, 2D, 3D drawing data and other 3D model data can be imported. UC1 series are the collection of software products that provides all-in-one solutions. It allows designing, calculation, and drawing application applied to various infrastructures, including bridge superstructure, piers, and road infrastructures. Some national standards are available on these software. So these are some of the UC1 design series product interfaces. UC1 bridge here, UC bridge is for design and calculation of the concrete superstructure. Seismic coefficient calculation is for calculation for the shared load of substructures. RC substructure design calculation is for design and 3D bar arrangement of the substructure of the reinforced concrete bridges. And lastly, the foundation design, 3D arrangement CAD, is for the foundation of various structures. Okay. The software can output reports as well as the detailed drawings. On the left, you can see the design calculation report, and on the right, the detailed drawings. The approximate quantities of the materials can be presented as well. There are different types of structures. These are different types of structures, sorry. With a 3D bar simulation, you can see the placement of the steel bars within the structure. You can check how these steel bars are connected or located before going onto the site. The design can be more accurate with this solution and can be beneficial for cost-effective constructions. There are plugins to check for the collision among the rebars. Now, let's see the interface of the UC1 series using pure 3D bar arrangement software. So, this is the interface of the pure 3D bar arrangement software. The window is divided into 4 different parts. And the bottom left here, you can see the real-time 3D model of the drawings. You can rotate and control to check the structure from different angles. So, and here in this window, this is the initial input window. You can choose your preferred standard reference standards here, and you can choose material, shape, reinforcement, design seismic coefficient, and load from this window. And after that, after confirming calculation, you can get the summary of result, and if necessary, you can go back to the input window. And from create create calculation sheets. You can check the results list, which is a report with the drawings of the structure you created, and reinforce bar information, beam, column, and also footing here, and other necessary information for the documentation. And from the Create a View, clicking this button, you can generate the drawings of the structure you created in detail. As you can see here, this is the section of the pillar. And you can also get the charts of the materials necessary for the construction. And these data can be exported with other CAD file formats. All right. And going back to the, yes. And from lastly, create 3D reinforcing bar window. The 3D bar arrangement viewer opens, and you can check the 3D bar, like bars within the structures, and how it's located, and if there's any collision. But for checking the collision, we have these plugins. Okay. So going back to the presentation, from now on, I'm going to talk about Engineer Studio. So, Engineer Studio is a finite element method application. The structure can be modeled in the software. It allows user to conduct dynamic and static simulation and linear and nonlinear analysis of the structure. The parts of the structure will be input depending on its nature of the material, with the standard element including frame element, fiber element, beam element, plate element, and cable element. Let's see the example that uses these elements. Steel arch bridges are usually modeled with frame elements, as shown in the screen. The reinforced concrete structures like eccentric piers are modeled with fiber elements. It is called fiber elements because the section of the structure are divided into the very small areas as shown in the image here. This is an underground drainage pump station. These box-shaped structures are usually modeled with the plate elements. As you can see, the walls here and slabs here are divided into square and triangular primary elements. This data consists of more than 60,000 nodes and more than 20,000 primitive elements, as you can see here. The software can handle these large-scale structures. One more thing, this drainage pump station is placed underground, and to determine the ground pressure and underground water pressure, another software called ULLC, it's mentioned here, is used. I will talk about the ULLC software later on in this presentation. Next, cable elements are used for the large-scale bridges. The image shows the movement of the structure under the influence of an earthquake. Magnitude can be customized according to your requirements. And using Engineer Studio, FORUM8 has won many awards since its release. Here's a blind analysis contest where we were commended as the champion in 2010. So let's check out some videos. So as you can see, this is a 1-to-1 real-life scale experiment imitating the seismic movement of an earthquake. And another video here. And this video shows our software model export of the result by Engineer Studio for the distraction analysis of the seismic resistance experiment. Okay. We also won the Risk Management Award and several other awards with Geoengineers Studio in Japan and overseas. We are honored to be able to provide the software recognized all over the world. So from here, I'll explain about the product called FEMLEague. FEMLEague allows a brief yet accurate on-site FEM analysis. In the image at the top right here, the substructure of the bridge is interconnected to its superstructure. Interrelation and the complicated joints of the superstructure and substructure of the bridge can be easily handled with this software. In the FEMLEague solver, in the blue box, in the middle, there are various choices depending on the types of result users are seeking for. You can combine and/or use externally provided solvers. For instance, you can use the external structure analysis solver called Nastra and Mark at the top. The complex and/or large structure can also be determined as shown in the image here. They can be easily divided into a mesh. The results can be output in a various types of diagrams. With simple section drawing in the middle top here, macro design can be procedurally generated by utilizing the function, this function. FEMLEague package now supports 64-bit architecture. It is now able to handle large data for large-scale models. So from this point on, we'll be looking at geotechnical analysis softwares. Today, I will be talking about dynamic effective stress analysis for ground, UWLC, the fourth from the top, and Geoengineers Studio, the third from the top here. So dynamic effective stress analysis for ground, UWLC, is a 2D dynamic land deformation analysis using FEM. When designing structures underground, the pressure from the soil around and the groundwater pressure should be considered. This software allows user to calculate the land transformation during an earthquake and the liquefaction. It can be output with the by-hour timeline as well. UWLC can be utilized in the investigation of structural stability and the interrelation of the soil and the structure by simulating vibration experiments during and after the earthquake. This is an analysis case study. Box culvert is a square tube shape, usually made with reinforced concrete. This image shows the section of the box culvert in the ground. The box culvert is modeled with the beam element, and the ground is modeled with plane strain element. And this is the result. It presents with the different outputs. You can see the deformation diagram on the left and cross-section force diagram on the right. So let's see how the interface of the UWLC looks like. Here we go. This is the input window. And after inputting, you will be able to get the results from the processor, post-processor window. And as seen in the presentation, this is a model diagram. And we also have different diagrams that represent the result, displacement to stress. And you can also check out the displacement in X direction here. It can also generate animation. For example, the deformation diagram here. We can watch. Here we go. You can see the movements in animation, displacement, deformation in animation. Okay, so going back to the presentation, oops, okay. So Let's move on to Geoengineer Studio. As ULLC was about the dynamic analysis of the interrelation of the structure, ground, and underground water, Geoengineer Studio is the static analysis of the different stages of the construction. For instance, excavation of the soil for tunneling, the calculation and the analysis of the construction, and also the impact on the surrounding earth, etc. Let's see the Geoengineer Studio and check out the interface straight away. Today, we will look at two sample data. First one is the sample data for the tunneling. For this project, you can see the construction process is divided into 6 different stages here. And you can customize depending on your project, of course. And each stage is analyzed separately. And we can check the result from the post-processor window. And you can see here 1 to 6 different stages results are generated with different diagrams. So let's check out the distribution of shear stress here in the first stage of the construction and the last stage of the construction, as you can see here. Okay. And we have another example. This is with this software, you can also check the influence on the structure in adjoining land. And this is about excavation of the ground and the retaining wall construction. So here, the middle of the land is a construction site, and there is a pier with foundation adjacent to the site. We are looking, from the post-processor window, we can check the result. And we're going to be looking at contours of displacement in X direction in the first stage of the construction and the last stage of the construction, like this. In the actual project, there could be a train line above the pier and a small misplacement to the structure of the pier like this can lead to a severe accident. So Geoengineer Studio is useful for the safety of the construction and the surroundings. Okay, moving on, going back to the presentation. I will be talking about the example of FEM analysis support service and technical service and NARDA prize winning works. So we provide data input service for clients overseas as well as clients in Japan. We provide quotes from the basic analysis of the condition and environment of the project after receiving the order here. Our team will work on the data creation using Engineer Studio based on the information and requirements customers provide. The data will be delivered and we provide post-transaction support and service. We offer services to bridge between softwares. For instance, we input data from our various software into Engineer Studio. This is a sample data of an oblique pi bridge, which is the trending type of bridges in Japan. And we can also check out the interface of Engineer Studio. So this is Engineer Studio software interface, and the oblique pi bridge is already modeled with a frame element. We can check out the section of the bridge here. This is the superstructure part of this, the section of the superstructure part. So we can see here these gray parts are the concrete, and this small dot represent rebars. And this larger circle represent pre-stressed concrete cables. And after inputting data from this window, FEM analysis could be done. And you can also get the result here. And this result can be presented in animation, like this. Will take a bit of time. Yep. We can see the animation. This animation shows the displacement of the structure under the influence of an earthquake. After the vibration, receiving the vibration, the structure starts to move significantly. Okay. Going back to the presentation. So we also provide data input service for inundation and tsunami analysis into VR Design Studio using Road. It is used for facility planning of sewage pipelines, simulation of irrigation pond failure, etc. Let's check out the video here. So this is a town or city visualized in VR Design Studio using Road, and it can represent the sewage pipeline underground here, as you can see in the video. And we also provide service to export the inundation analysis result to visualize it in this environment, as you can see. And we also provide this service for the tsunami analysis as well. We have another video here. This is the seaside city. And as you can see, the tsunami, the surface of the ocean or sea, you can see visualized here. Okay. And we also provide 3D VR flood hazard map service. And we'll be able to open the software on the VR cloud. So this is a sample data of the possible severe flood in Minato City, where FORUM8 head office is located. The green signs above the buildings indicate the location of the shelters. This can be the open source for people who live in the area and for them to physically, visually know where to go or which part of the city should be avoided in the emergency situations. So this was the service we provide to input analysis data to using Road and VR clouds. And moving on, we will talk about NARDA award, which stands for National Resilience Design Award. And NARDA is an annual contest organized by FORUM8. Clients using our software solutions can enter this contest and report the result of their project to participate in NARDA. And here's a project that received our Grand Prix. They used Geoengineers Studio. Let's check out the video here. So here, Nihon Suiko Consultant compared 2D section element models and 3D plate element models for the same structure regarding their seismic resistance. The bending check result of the two respective models were compared. In the result, ranges that were deemed not feasible from the 2D section model were deemed feasible when using the 3D plate element model. In the analysis model of the 2D section modeling, the effects on the element linked in the direction of depth was not considered, but in the 3D plate element model, the actual behavior of the form and shape was able to be realized. For this project, from the skeleton form, the 3D plate element modeling's analysis result was concluded as valid. Countermeasure work, which could be used against damage results, was considered. So, excuse me. So, this concludes our brief introduction to UC1 series and Engineer Studio. Again, I am Hinako Kyotani. Nice to meet you all. Thank you so much for listening.
And there we go. Okay. So next, for this last bit, for the next 30 minutes, I'm going to be talking about, whoop, that came up there. I want to be talking about Iem and VR, which is our kind of way of how we're saying how we bring it all together. So today we've introduced quite a number of our software family that we have with us today. Sorry, that's in the background loading and it keeps popping up. So we have our kind of platform software, VR Design Studio, UC Winroad. And then we also have our modeling software, which is 3D, and then we also have the UC1 series and Engineer Studio series that Hinako was so kindly introduced to us. But now, how do we bring it all together, and what are we doing with all this software? So we have a pretty map that we have here, and I know it's quite a bit of information here, but as you can see, we have VR Design Studio, UC Winroad here at the middle. And it's connected to every single software that is within the FORUM8 software family here. As you can see on the bottom right here, we have our UC1 series going on in the top right. We have the Engineers Studio. We also, in the very top, we have the FEM software. In the bottom, we've got our Shade 3D. And then on the left side, we've got our various plugins that support with third-party software as well. We also fully support Allplan if you are an Allplan user as well. And while it's pretty interesting to see it like this visualized in this kind of map, it's a little difficult to understand. So in the sense of the BIM process that is going on. So you start with your investigation, your surveying, and your design here on the top left. And once you've decided that you need to adjust with construction, or building, then you move into the construction phase. And before your construction, in your pre-construction phase, you go through your design process. And that utilizes, I mean, if you want to utilize some of FORUM8 software, you can, or you can utilize your own software, and then you can design, begin the design process. And then once the design process is completed, then you run through your visualizations, you run through your analysis, you run through your testing, and then you start the actual construction, and then you finish your construction. Now, once the construction is finished, you begin your sustainable management of that construction project. So then you begin the analysis and surveying again, and this whole process then repeats. And this is the kind of idea with BIM that we have going. So with this kind of FORUM8 environment, we offer a lot of different, opportunities to expand on and analyze the different levels of detail. If you're not familiar with the BIM levels of detail, you have LOD 100, which is just the basic model representing the location a target would be in, and then the level LOD 200, which is the general idea of what the structure, kind of a rough sketch of what the target object can be understood. So as you can see here, we have, like in the bottom left, we have just a simple design. And then as your level of details increase, you have more explanations and more analytical opportunities to understand what kind of model you are creating. And with the just aforementioned UC1 design series, we can create models from LOD 200 all the way up until 400 within the series itself. And just to kind of understand how these all work with VR Design Studio, as you're designing your models, maybe within the LOD 200 to 300 range, utilizing UC1 design calculation or implementing your rebar, you have your BIM model created. You can export it as an IFC model, and then that model can then be visualized within UC Road. You can check the placement, you can check the organization, you can check where you want it to be, and then you go back to the drawing design board, or you continue on that design. Then you start getting into more advanced models. Then you have your LOD 400 model. This can also be designed within the UC1 design series. Then you finish up completing your checks within the BIM model design. You export it again as an IFC file, and then import it back into UC Road to run through your final virtual checks and your simulation checks on the software. On your model. And then you can you proceed into the actual building of your model. We have the 3D parametric tool that was